Hi guys, welcome back to my YouTube channels, and in this video I'm going to share with you my learning note about forward and backward compatibility. So let's imagine that we have a client and a server. They can communicate each other because they are agreed on some contract beforehand or a schema. Because by using a schema, only then both can understand the context of the data that is being retrieved or is being sent. And in some point, we need to upgrade or update the schema, which is it's being called schema evolution or schema versioning in computer science. And when we're doing that, we have to make sure that the system is able to run correctly to maintain the functionality without breaking the entire system. So how to evolve schema without breaking the product? Then we need to apply one of the or more than one compatibility types. So we are going to discuss about backward compatibility, forward compatibility, full compatibility, and no compatibility at all. Backward compatibility, it means that a software or hardware that can interoperate with an older version of itself. For example, if I have a code written in Go version, let's say 1.14, and then I run it and compile it in Go version 1.18, the code is still able to run correctly. It means that the Go language has backward compatibility. Backward compatibility has pros and cons. The pros is it preserves the investment made in older software or older hardware. It adds value and incentive to purchase new hardware, especially if buyers know in advance that not only can they use previous software, but they will also be able to count on forward compatibility for future generations. For example, like PlayStation 5 is able to run a previous game from previous version of PlayStations. And to be specific, in gaming, like newer hardware that run older application or games may also have a better visuals or frame rates. So it is allowing the user to have a better experience without having to purchase a new application or games. The cons is the cost of supporting old software is huge drawback for the developer. It is increased complexity and it can increase the time to market the product. There can be also a technological hurdles and slower innovation because we have to support the older versions of the software, and sometimes we cannot have innovation because it will break the older software. Let's discuss about forward compatibility. It is a software or hardware that is able to interoperate with the future version of itself. So it's like we have a roadmap directed at compatibility with future products. For example, the Game Boy is able to play certain games released for the Game Boy Color, which is the next version of the Game Boy. It is possible because these games utilize the same cartridge design as games for the original Game Boy. The pros and cons for forward compatibility are allow extending behavior without breaking the contract, while the cons is it is hard to implement because of unknown feature behavior. So that's why we need to have a very solid understanding and uh, a scope of the projects so that we can have forward compatibility. And the second cons is older hardware that can use newer applications or games may also have inferior performance. Now let's talk about full compatibility. So it is basically a combination of backward and forward compatibility, which is a software or hardware that is able to interoperate with the future version and an older version of itself. For example, if I have a device with USB version 1, it can run a device with USB version 3. Of course, we will lose the speed of USB 3, but we still can use the USB. And in the other way around, if we have USB version 3 device, we're still able to run USB 1.x device. No compatibility. It means that a software or hardware that doesn't have compatibility at all, so they disable it. For example, if we have API and then we change the field type from number to string, or we rename one of the fields in the payload, so it's a breaking changes, so it doesn't have compatibility with previous or the next version of itself. Now I'm going to talk about compatibility in the scope of producer and consumer. In order to have the same meaning, in order to have on the same page, I would like to discuss about the terms regarding the producer and consumer. So producer means that the service that creates the data. So it's provide the data. And consumer means that the service that parses, reads, or uses the data. So if we have a server and client, the server can be producer or consumers regarding the roles, right? If the server creates the data, then it is a producer, or if the server is consume the data from the client, then it is consumer. So this is the diagram of backward and forward compatibility. Backward compatibility means that a consumer with a newer schema can correctly parse data from a producer with an older schema. Forward compatibility means that a consumer with an older schema can correctly parse data from a producer with a newer schema. Example of backward compatibility. So let's imagine that we have consumer and producer. Producer, the clients want to create a to-do, so it sends a payload to consumer. The consumer has upgraded the version of itself to version 1.1, which is it introduced a new field label. So the older producers, which is sending the payload without the label, can still send the to-do, and the to-dos can still recognized by the consumer, and the consumer creates the to-do. It just ignore or empty the label. So if the consumer is able to understand the context, even they have different version, it means that this consumer has backward compatibility features. So naturally backward compatibility changes, like I have mentioned before, is adding new optional fields, adding new optional query parameters, adding new responses, adding a field with a default value, widening a numerical type, let's say from integer to float, adding a value to an enum string, and removing a field. So these kind of changes are naturally in a backward compatibility. So backward compatibility benefits are we are able to upgrade consumers without having to upgrade producers for adding new input. And there will be no data loss because we are still able to read data from older producers. Now let's take a look about example for forward compatibility. Now let's say the producers have upgraded themselves to version 1.1, but we need to downgrade the consumer to the previous version 1.0. So the producers send a payload of to-do request with a new label. If the consumer still able to recognize the payload, the contract, and creates the to-do, even though there is an unknown label that the consumer of version 1.0 doesn't recognize, then this consumer has a forward compatibility features. But if the consumer recognize this is there is an unknown field in the payload, which is the label, and then it marked as a bad request, then the consumer doesn't have forward compatibility features. So it's back to us whether we want to enable the forward compatibility. In this case, maybe security is a concern, then we will sanitize any request with unrecognized fields. So naturally, forward compatibility changes are adding a new required field, narrowing a numerical type from float to integers, or removing or adding a value from an enum string. The benefit of doing forward compatibility is able to upgrade producers without having to upgrade consumers for adding new input. So if a company adopted backward and forward compatibility philosophy, then it means that they have to commit to backward and forward compatibility beyond more than one product generations. And then they also have to ensure that there is always an upgrade path from previous generation products into the latest one with only minor alternation required. And the last one is certify compatibility through stringent testing. Let's discuss a little bit about compatibility testing. Backward compatibility testing is a technique to verify the behavior and compatibility of the developed hardware or software with their older version of the hardware or software. Backward compatibility testing is much more predictable as all the changes from the previous versions are known. For example, Samsung releases a new Android UI, and they will test their platform to make sure that they are backward compatible with older application and hardware as well. Forward compatibility testing is a process to verify the behavior and compatibility of the developed hardware or software with the newer versions of the hardware or software. Forward compatibility testing is a bit hard to predict, as the changes that will be made in the newer version are not known. Example, there is a client's plan to upgrade the Salesforce CRM version, and the plan is halted because their customized database would not be stable with the latest versions. What if breaking changes is not avoidable? So we need to handle them. And how to handle it? Let's take a look. There are two options to handle breaking changes. The first one is by expand and contract. It means expand the payload by adding a new field without modifying the old field. And then, at a later stage, the old field will be decommissioned once all clients already use the new contract. So there are two steps: expanding the field and upgrading the contract. The second option is version bump, which is creating a new version of the API and deprecating the old one. At a later stage, the old API will be decommissioned once all clients already use the new API. Let's take a look at example of expand and contract. For instance, we have a consumer with version 1.2. In version 1.2, we want to change the field name of description to content. So this is a breaking changes. If there is a client or producers that already upgrade the version to 1.2, then their payload will already have content that replacing the descriptions. For a producer that's still in the previous versions, they will still send the payload with the field name descriptions. Right. So in the consumer code logic, expanding the payload means that the consumer is still able to recognize two kinds of requests. The request that with the field name descriptions and the request with the field name content. And then once all the producer have upgraded their version to 1.2, then the consumer will deprecate or decommission the field name descriptions. The pros of using expand and contract is it is ideal for internal or private API because developers have control over the contract. We can ask the commitment for the clients in our internal system to upgrade their version of API. And the cons is it is not ideal for public API where developers do not have control over the clients and end up having a lot of duplication in the code, which is because we have to maintain the two fields, but they are basically referring to one same data. Therefore, if you have a public API, most likely you will do the version bumping. So for example, we have service that run in version 1.1 as it is, but we also create a new services version 2.0. At later stage, we will route the request, right, coming to consumer 1 or consumer 2 depends on the API they call. Example of versioning. We can do versioning by path-based versioning. So we specify the version in the URL path. Or we specify the version in header. By using custom header, for example, accepted version and then the version that we are going to use. Or we can use standard header like this. So we are going to use accept as the key of the header, and then this is the applications MIME type /fnd or vendor dot to do is the application name plus JSON is the serializations, and then the version that we are going to use. Summary. Backward compatibility on the consumers ensures that older producers can still send the requests and parse the results. Backward compatibility is easy to understand because we already understand the previous behavior, but it is not easy to maintain. Forward compatibility ensures that older consumers' methods can still be called by newer producers. Forward compatibility is hard to implement because it needs a well-defined roadmap and scope. For an internal API or private API, probably does not require forward or backward compatibility. It's because microservices tends to have a great isolation and therefore freedom. But it's back to your specific use cases. Breaking changes should be avoided, especially in public API, right? Where you will really need to be backward compatible and forward as much as possible. But if we have to introduce a breaking changes, then we can try to expand the API or create a new version of the API. So that's everything that I want to share with you in this video. I hope you can learn something new from this video. So I'll see you again in the next video. Keep learning and stay healthy. Thank you for watching, and bye-bye.